Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over rounding off answers derived from addition and subtraction. So just like in my last video, we went over how to round off answers that were derived from multiplication division, and we talked about how the rule that you're following in there is that the answer that you calculate should have the same number of significant figures as the number or the value that the inexact value that has the least number or fewest number of significant figures. However, when you're adding and subtracting, the rule is different. And there, the rule is that you are to round your answer to the same number of decimal places as the inexact value with the fewest decimal places. So let me show you an example of how this works. So here in this problem, we're given a lab procedure that is calling you to find the mass of an unknown liquid. And so let's say, so you start off with an electronic balance. You put your empty beaker on the electronic balance, and you find that it reads 52.3812 grams. And then you go ahead and you put the liquid into the beaker, and then you reweigh the beaker and you find that the balance isn't able to read it. There's too much weight. And you go and find another balance, and this is like a 30-year-old balance, and you put it on there, and this is the beaker and the liquid together, and it reads 60.2 grams. So then to find the mass of the liquid, you need to subtract out the mass of the empty beaker. And so when you do that, you go ahead and, okay, so the 60.2 grams, that was the mass of beaker plus the liquid. We want to get rid of the beaker. So we're going to subtract out the mass of the empty beaker. So we're going to subtract that out. So we're going to subtract 52.3812 grams. And the calculator is going to give us the answer. What did I calculate? So 7.8188. So 7.8188 grams of mass. So that's what the calculator gives us. But can we keep all of those digits? And the answer is no. We gotta pay attention to the rule. The rule is, again, that the number of decimal places that we have here should be the same as the number of decimal places, the fewest decimal places in the exact measurement. So we look at our inexact measurements here, and whatever one has the fewest number of decimal places, our answer is going to have the same number as that. So let's look at decimal places. So now one thing I want to say before we get into this is that this idea of decimal places is kind of a little bit I can't think of the word I want to use. It's a little bit confusing, or I would say misleading. That's the word I want to look for. So it's a little misleading because when you think of decimal places, you're thinking of places after the decimal place. So this has 1 decimal place, this has 4 decimal places, and so on. But the better way to think about this is what's the least, which inexact value has the least precision? Or another way to think about it is what's the last place that's being held by a significant figure in your decimal, in your value, right? Because you could have something that's like, say, instead of 60.2, you could have 60, right? And the last digit here is in the ones place, right? You would say there's no decimal places there, right? So maybe it's the least decimal place. Or the last, it could be that since there's no decimal point here, the only significant figure in this measure, let's say this is 60 grams, that 6 is the only significant figure. So really, the least decimal place is the tens place here. So if I'm going to add this with some other number, Sorry about that. So if this is our 6, this is the only significant figure, then if I add anything this, let's say I subtract this from this, then the least decimal place is actually the tens place. It's not the 0 place here, because the last digit of significance in this measure is actually the tens place. So my answer should only be given up to the tens place, and anything after that would have to be held by a 0 or some sort of placeholder. So I'd have a 0 there in the ones place to hold that, and I wouldn't have any zeros after the decimal place. So the better way to think about it is, instead of decimal places, you want to think about it in terms of which place is the least significant, not least significant, least precise. Which measurement has the least precision or has the place where it's the least precise. So tens place here is the least precise one. Sorry if that's not clear. It's really hard to speak about this in terms of decimal places. So I hope that is helpful. Maybe I'll do an example of that after this one. All right, so here's my answer. So we're looking at which value has the least precision, which means which value has the least or fewest number of digits that go to the right? So here, this has one digit that goes to the right of the decimal point here. So that's 1. So this has one decimal place. And then this one has 4. So our answer should have the same number of decimal places as the inexact value with the fewest decimal places. This has the fewest since it's 1. So that means our answer can only have one decimal place. So everything after the first decimal place is eliminated. This is a 1, so we don't need to round the 7. We don't need to round the 8 up to 9, so it's 7.8 grams would be the recorded mass of the unknown liquid. Now, what if instead of 60.2, let's say it reads 60 like I said before? So in this case, if I subtract out if I subtract this out, I would get, so if I subtract out, let me lower this here a bit so I'm not in the way. So 60 grams minus 52.3812 grams. So let's say, for the sake of argument, that my 30-year-old balance that I got out of my cupboard reads 60 grams. And here the last digit of significance is in the tens place, not the ones place. So I subtract this out and I get what value? And the answer is 7.6188 grams. So again, the question is, how many digits am I allowed to keep in my answer? Now again, it says fewest decimal places here, but this has no decimal places. So you might be tempted to write, oh, well, this has 0 decimal places and this has 4. So then our answer should have 0 decimal places. So we cut off the 6, right? So we cut off everything after the 7. That's a 6, so that means we round this to 8. So the answer should be 8 grams. And that would be understandable, but that would be incorrect, because the last digit of significance is the 6, because we don't have a decimal place here. So since we don't have a decimal place, then this 0 is not significant. So the 6 is the last one. That's the tens place. So when we figure out the numbers that we should keep, what digits we should keep, this is the last place of of significance. So whatever place your last place or your last digit of significance is in, that is going to determine the place that you write your answer in, with the last place of significance you're going to have in your answer. So then here, if I subtract, I get this number. So then the tens place is the last digit of significance. That's the last place of significance. Here, it's I believe that's the 10,000ths place. So of course, this is the least, this is less precise. So we're going to have to keep the tens place. So the tens place is the only place of significance. So here we have, if I move this over, this place here is the place of significance, right? So here we have a 0 there. So then this 0 gets raised up. If we drop it off of there, then that's going to become a 1. And so this is going to be 1. And then we put a 0 there as a placeholder. And so 10 grams would be the value that we would write. So that would be the proper recording. So I hope that helps. If that doesn't make sense, or if you need more help, please by all means ask me questions. I'd love to hear from you. So if this video was helpful in any way, if you enjoyed this video, please by all means like this video, share this video with your friends, hit that like button over there somewhere, and then also make sure you hit that notification bell so that way you can be notified by all the videos I put out. Click all, by the way. And in addition to that, please put a comment down below. Let me know what you think. Ask me questions if you need more help with this. If you have any comments, please make them. I would love to hear from you. Thanks for joining me, and have a great day.